Hi friends, welcome to my channel. This topic is related to civil engineering, strength of material subject, drawing shear force and bending moment diagram for shown in below figure. This is a simply supported beam with a point load at mid span 5 kN, 4 meter span. So, shall we start the solution? Solution for it. First step is free body diagram. FBD, free body diagram. Removing the supports and placing reactions is our first step. Free body diagram means removing supports and placing reactions for the beam. RA, RB. C, 5 kN, 4 meter span. The load is acting 2 meters from reaction A and C2 RB 2 meters span. Second step is reaction calculation. Reaction calculations. For these reaction calculation purpose, we are taking summation of upward forces is equal to summation of downward forces. The upward forces are RA, RB. RA plus RB. Summation means plus. Downward forces are 5 kN. It is our first equation. Then taking moment about A. Moment about A. Here clockwise, I am assuming clockwise positive and anti-clockwise negative. Then moment about A, I am calculating. RA, RB is creating anti-clockwise movement to RA. Minus RB, movement means load into distance. So RB into 4 meters. 5 kN is creating clockwise movement to A, RA. So plus 5 into 2 meters is equal to 0. This is minus RB into 4 plus 10 is equal to 0. Minus RB into 4 is equal to minus 10. Minus cancel. RB into 4 is equal to 10. RB is equal to 10 by 4. 10 by 4 is equal to 2.5 kilonewton. RB is 2.5 kilonewtons. Substitute RB in equation 1. Our equation is RA plus RB is equal to 5 kilonewton. Then we substitute RB in this equation. RA plus RB value is 2.5 minus is equal to 5 kilonewton. Then RA is equal to 5 minus 2.5. RA is equal to how much? 2.5 kilonewton. We calculated the reactions RA and RB. Here RA is equal to 2.5 kilonewton and RB is equal to 2.5 kilonewton. Then our third step is shear force calculations. Shear force calculations. To calculate shear force, I am taking a section about A. Section about A. Shear force at A is equal to how much? Shear force at A is equal to load at that section or force at that section. I am taking left side upward forces are positive and downward forces are negative. So section left side force is RA. Left side force upward is positive plus 2.5 kilonewton. Next, shear force about C. C is point load. So for this point load, I am calculating section before C and after C. Before C, the force is A, RA. RA is upward force positive 2.5 kilonewton. Then shear force at after C. Shear force after C. C ki tarvata. C. Shear force at after C means 2.5. Section ki left side force plus 2.5 and section ki left side, but it is acting downward. So minus 5 is equal to minus 2.5 kilonewton. 5 है ना? Next, shear force at B. We have only 3 forces. So shear force at B, I am taking section from right side. It is B 2.5. Right side upward forces are negative, downward forces are positive. So right side upward force means 2.5 kilonewton. It is negative. Then fourth step, calculating bending moment. Bending moment calculation. Bending moment. Bending moment about A. Bending moment about A. I am taking section here. Bending moment about A. A is 2.5. At A, I am calculating bending moment. The distance is 0. A to A is 0. Here, sagging moment is positive, hugging moment is negative. It creating sagging moment. So, plus 2.5 into 0 is equal to 0 kilonewton meter. Bending moment about C. About C, I am calculating bending moment about C. C is creating, first of all A. A movement means force into perpendicular distance. How much A to C? The distance is 2 meters. Okay, 2 meters. A is 2.5. It creating sagging moment. See, beam is like this. The load is creating upward. So, it is sagging moment. Plus 2.5 into distance is 2 meters. And again, C is creating downward sagging moment. 5 kilonewton. Minus 5 into at that distance is 0 is equal to how much? 5 kilonewton meter. Next, bending moment at about B. I am taking section here. And bending moment about B, it is 2.5. At that section only I am calculating bending moment. So, it is sagging moment plus 2.5 into 0 is equal to 0 kilonewton meter. We are calculated shear force and bending moment, diagrams. Okay. This is our beam. A, B, it is C. 5 kilonewton load from 2 meters, 2 meters. Here C, shear force and bending moment diagram. First, shear force at A is plus 2.5. So, I am taking plus 2.5 upward, and at before C also it is 2.5. 2.5 means it is straight line. Next, C, after C it is minus 2.5. It is minus 2.5. To B is minus 2.5. Same, continue this line to B. It is positive 2.5. It is negative 2.5. We have to make these lines for shear. It is shear force diagram SFD. Shear force diagram. Next, bending moment diagram. See, bending moment at A is 0. So 0. A is equal to 0. Next, bending moment at C, 5 kilonewton meter. Here I am taking 5 kilonewton. It is linear. And B also 0. It is also linear. Straight line, linear. It is 5 kilonewton meter. Here to here. 5 kilonewton meter. Positive. Bending moment diagram. C, B, C. Okay friends, this is our problem. Shear force and bending moment is done.